Good afternoon, everyone. Welcome to I² Maths Academy, where numbers and variables actually meet mastery. Today, we are going to be looking at integration of this form. Yes, integral the x all over a plus b sin square x plus c cos squared x. Yes, we are going to be looking at integration of this form. Now, when you have a function in this form, the idea behind this is to substitute. Yes, it is to substitute t is equal to tan x. Yes, t is equal to tan x. Now, we're going to be looking at some examples. Yes, now let's look at example 1. Example 1. Yes. Now solve integral the x all over 4 sin square x plus 9 cos squared x. Yes. Now, as you can see, this integration, the integral here is of this form. Yes. So now we say the idea or the principle behind this is to substitute c is equal to tan x. Now, before this, now we all know, recall from trigonometric substitution. Yes, from trigonometric identity rather. Yes, from trigonometry identity. Yes, we said sin square x plus cos square x is equal to 1. Yes, this is an identity. Sin square x plus cos square x is equal to 1. Now, if sin square x plus cos square x is equal to 1, it means sin square x will be equal to 1 minus cos squared x. Yes, 1 minus cos squared x. Now, it therefore implies that 4 sin squared x plus 9 cos squared x will be equal to, here we have 4 in brackets, 1 minus cos squared x, and here we have plus 9 cos squared x. Yes. Now, expanding this, here we have 4 times 1 is 4 minus 4 times cos square x is 4 cos squared x, and here we have plus 9 cos squared x. Yes, plus 9 cos squared x. So therefore means that the whole of this now will be equal to, yes, the whole of this will be equal to 4 minus 4 cos square x plus 9 cos square x is plus 5 cos squared x. Yes, 5 cos square x. So it therefore implies that the whole of this integral the x all over 4 sin squared x plus 9 cos squared x is the same thing as saying integral, we have the x all over the whole of this now. Yes, that is 4 plus 5 cos squared x. Yes. Now, looking at this now. Now, integrating the x all over 4 plus 5 cos squared x. Now, we can see that this is of this form. Yes, where we have c cos square x, 5 cos square x. Now, remember we said the idea behind this is to substitute t is equal to tan x. Yes, t is equal to tan x. So here we tell them, let t be equal to tan x. Yes, let t be equal to tan x. And of course, if t is equal to tan x, it means the t all over the x, when you differentiate tan x, it gives sec squared x. Yes, it gives sec squared x. And we all know, yes, we all know that sec squared x is the same thing as 1 plus tan squared x. Yes, 1 plus tan squared x. So it therefore means that the t all over the x is equal to 1 plus, remember here we said let t be equal to tan x. So it means tan square x now will be t squared. Yes, it will be t squared. So here the t will be equal to 1 plus t squared. Then here we have the x. 1 plus t squared dx. Now making the x the subject here, it means the x will be equal to the t all over 1 plus t squared. Now please let's take note of this. The x is equal to the t all over 1 plus t squared. Now let's come back to this. Now if t is equal to tan x, yes, if t is equal to tan x. Now let's figure this down. Let's bring out our right angle triangle. Yes, now the angle here is x. Yes, the angle is x. The angle is x. And remember, from trigonometry, let's flash back to SOHCAHTOA. Yes, SOHCAHTOA, where this s here actually represents sine. Sine is opposite all over hypotenuse. Cosine, that's cos, is adjacent all over hypotenuse. And t here represents tangent. Yes, tan is opposite all over adjacent. So here, the side facing our given angle, which is this side, is the opposite. So here we have t. Now the side facing our angle 90 is the opposite, is the hypotenuse rather. Yes, the side facing the given angle is the opposite. The side facing our right angle here is the hypotenuse, and this side is the adjacent. So here this is the same as 1. Yes, tan x is equal to t, and we know that t is the same as saying t all over 1. So here now let's look at the value of sine. Let's look at the value of sine x. Yes, let's look at the value of sine. Let's look at the value of cos x. Now cos, we say cos is adjacent all over hypotenuse. So the adjacent here is 1. So we have 1 all over hypotenuse. Yes, but before then, now let's look at this now. Let's get the value of the hypotenuse. Yes, let's call this z. Now remember from Pythagoras theorem that the hypotenuse square is equal to the opposite square plus the adjacent square. So it means our z square will be equal to t square plus 1. So the value of our z will be equal to the square root of t square plus 1. Yes, that's z. So it means this side is the square root of t square plus 1. Yes. So now going back to cos x. Now cos x, we said cos is adjacent all over hypotenuse. Yes, adjacent over hypotenuse. So here, the adjacent side is 1. Yes, the hypotenuse is the square root of 1 plus t square. Yes, or t square plus 1. Now that's cos x. Now let's look at cos square x. Yes, cos square x. Now this cos square x is the same as cos x all squared. So that will give us 1 all over the square root of 1 plus t square. Then here we have all squared. Yes, all squared. So it therefore means that cos square x, yes, cos square x will be equal to, we have 1 all over, yes, the square root of 1 plus t square times 1 all over the square root of 1 plus t square. Yes, that's the square root. So it therefore means that cos square x will be equal to 1 times 1 is 1 divided by the square root of this times the square root of itself. It will give us 1 plus t squared. Yes, now let's take note of this. Cos square x is 1 all over 1 plus t squared. Yes, now let's do it now. From the question, we have 5 cos square x. So let's see the value of 5 cos square x. 5 cos square x will be equal to 5 times the value of cos square x, which is 1 all over 1 plus t squared. So that will give us 5 all over 1 plus t squared. Yes. Now we also have 4. 4 plus 5 cos square x. So here 4 plus 5 cos square x will be equal to 4 plus the value of 5 cos square x is 5 all over 1 plus t squared. Now this 4 is the same thing as 4 over 1. Now let's see the LCM of 1 and 1 plus t squared. So the LCM is 1 plus t squared. Yes. Now 1 into 1 plus t squared is 1 plus t squared times 4. It becomes 4 in bracket 1 plus t squared. Then we have plus 1 plus t squared into 1 plus t squared is 1. 1 times 5, that will give us 5. Yes. So it therefore means that 4 plus 5 cos square x will be equal to 4 times 1 is 4 plus 4 times t squared is 4t squared plus 5. Now all over divide by 1 plus t squared. So it means 4 plus 5 cos square x will give us 4t squared plus 4 plus 5 is 9. So here we have 9 all over 1 plus t squared. Yes, all over 1 plus t squared. So that's the value of this now. Yes, that's the value of our 4 plus 5 cos square x. Now let's look at 1 all over this value. Yes, so 1 all over 4 plus 5 cos square x will be equal to 1 all over, we have 4t squared plus 9 divided by 1 plus t squared. So this will give us, it will give us 1 plus t squared divided by 4t squared plus 9. Yes. So now we have seen the value of 1 all over 4 plus 5 cos square x, which is the whole of this. Now let's bring out the integral. So it means integral 1 all over 4 plus 5 cos square x, the x, will be equal to integral, the whole of this now is this, 1 plus t squared all over 4t squared plus 9. Then here we have dx. Now let's go back to the value of our dx. Now look at the x here. Now let's look at this now. Yes, this is the value of the x. Yes, this is the value of the x. We said the x is equal to dt all over 1 plus t squared. It therefore means that here we have the t all over 1 plus t squared. Yes, that's the value of the x. So this 1 plus t squared will go with this 1 plus t squared. So it means we'll be left with integral 1 all over 4 plus 5 cos square x. The x will be equal to integral, we have the t all over 4t squared plus 9. Yes, plus 9. So now we have to integrate this now. Now integrating the t all over 4t squared plus 9, this is the same as saying 1 all over 4 integral the t all over. Now this 4 is out. So here we'll be left with t squared plus 9 all over 4. Yes, plus 9 all over 4. Because when you multiply 4 times 9 all over 4, it gives 9. Yes, it gives 9. So here we have 9 all over 4. So the whole of this 9 is the same as saying 1 all over 4 integral the t all over, here we have t squared plus 3 all over 2 all squared. Yes, 3 all over 2 all squared is 3 all over 2 times another 3 all over 2. Now let's look at this again. So here we have the integral 1 all over 4. Yes, 1 all over 4 integral the value we have there, which is the t all over t squared plus 3 all over 2 all squared. Now will give us, now let's look at this now. Yes, let's recall. Now recall. Remember we said integral 1 all over a squared plus x squared, the x is equal to, we have 1 all over a tan inverse of x all over a plus constant. Yes, plus c. Okay. So now it means the whole of that function. Yes. It therefore means that 1 all over 4 integral the t all over t squared plus 3 all over 2 all squared, 3 all over 2 all squared will be equal to, so here we have 1 all over 4. Yes, that is this 1 over 4. Now the integral of this, now comparing with this, it becomes 1 all over the constant, and the constant is 3 all over 2. Yes, it's 3 all over 2. And here we have tan inverse, yes, tan inverse of x all over, so it becomes t all over a, which is 3 all over 2. Yes, which is 3 all over 2, the whole of this. Then here we have the whole of this, then here we have plus c. Yes, plus constant. So it means the whole of this now will be equal to, we have 1 all over 4. 1 divided by 3 all over 2 is 2 all over 3. Then here we have tan inverse of, here we have, this becomes 2t all over 3. Then here we have plus constant. Yes, so it means this 2 here is 1. 2 in the 4 is 2. So here we have 1 all over 2 times 3 is 6. Then we have tan inverse of 2t. And remember the value of our t, we said let t be equal to tan x. Yes, our initial substitution. So here we have 2 tan x all over 3. Then here we have plus c. So this is the solution to the question. Thank you so much for listening. Remember to like, share, and subscribe. God bless you.